Okay, so our next corrections, we go here to gravity. We've just done this import tab, so now we're going to move on to corrections. We're not going to do this first one, simulate absolute gravity. That's just calculating the absolute gravity at your area. So we're going to click on this next one that goes gravity correction. Okay, and so you can see in the background is my database, and the column we want to work with is this grav. So that's why input channel is grav. Output channel, grav corrections. Technically, you might want to add here drift corrections so that you know exactly what type of corrections have been done. Although I think you could actually say there's something else as well here, but I'll tell you now. Scaling. From what I understand, this is, I'm going to have to figure out later on with the Lacoste-Stromberg, because it's got a calibration factor that has to be taken into account here. So you can either have a scaling factor of 1, or if there's a table that goes with your gravimeter. Like I said, tide correction, if you've got the Lacoste-Stromberg, you might need to calculate it because it doesn't do it automatically, whereas the CG3 and the CG5 do it automatically. So we're not going to click on either of these. Instrument height correction. So this is the height, that alt channel, that's the height of the instrument above the ground. You saw here it was 16 centimeters. I always get my centimeters and meter conversion wrong. And this is the equation, so it's just for that small height. And then drift calculation. So this, you'll remember when you learned about gravity corrections, this is because of drift in the instrument due to stretching of the spring or due to tides that needs to be corrected. So that's why we do a base station at the start of the loop and at the end of the loop, is to see how much the reading at the base station has changed, because it shouldn't change. It's the same rock that you went to earlier. So any drift is due to these other factors and we need to correct it. So this drift channel is going to be this drift correction put there. Absolute gravity calculation. I think I'm a bit confused about absolute gravity. So to me, absolute gravity is that there are these points all around the Earth that have been surveyed in, and gravity is known at these points, and like they're very well, it's super accurate. And that if you wanted your survey to be accurate, but equally to be drawn into a larger survey, like if you wanted to combine surveys over a region, you would have to include this absolute gravity base station so that you could tie them in with each other. So I think I don't 100% understand why Geosoft is calling this an absolute gravity calculation, since we aren't tying it into something. But from what I understand, and I could be absolutely wrong, it's really just the drift corrected gravity. And so it's taking the gravity, it's taking the base station, doing the drift. I don't know. So I don't really understand why they're using the word absolute here. I think it confuses me a bit. More here, this is the date and time channel that it's automatically picking up. So we click OK. And you can see the drift is extremely small. And it should be small because there's only small changes between the base station. And then it gives us this drift corrected value that is huge. And then I think I got very confused at this point. I just want to see. I think we don't have the other channel. But don't worry, it gets better. Let's do the gravity correction, and then this should go down. So my supposition, and I could be completely wrong, is that this huge increase in value, you can see the gravity here is 6,000, it goes up to 900,000 over here, is linked with that instrument height correction. Let me go back. It's linked with this correction over here. And then once you've done the latitude correction, you get rid of this large value. But let's give it a try. Okay, so this is the drift value over here. And I mean, if you wanted to, sorry, you could click on the heading and say show profile, and you can see it's a slow drift over time. So remember, this is 1 day's worth of reading. It would actually be better if on our x-axis we put time. Let's see what time looks like. Yeah, you can see it slowly drifting by 0.06-ish. Okay, so now let's click over here. And so we've done the drift correction, and now we're going to do the latitude correction. And so input gravity here, we're going to input grav drift correction, corrected data. Then you're going to give the latitude channel, latitude correction channel. So this is the output channel that's being corrected due to latitude. Oh, no, sorry, ignore me. This is going to be the actual correction, and then the output channel here is grav. I'm going to add in the words lat correction, so we know that this is this drift corrected gravity that's now being corrected for latitude. I might even add in drift as well, so I know it's been drift and latitude corrected. And this is the method we're using, and we click OK. Okay, and so now you can see that my theory was right. I don't know if somebody can correct me. So the latitude correction itself is very large, and that brings down your final drift and latitude corrected data down to much smaller values. Okay, I'm going to stop the video there, and then I'll do the next corrections.